So welcome back. So we were on discussion. We needed to find the resistivity. We were given with the resistance from this graph, which is the reciprocal of the gradient voltage over current 10 by 5. The area was pi d square. So diameter is given as 5 to 10 upon negative 4 pi d square by 4 divided by the length, which is 0.8 meters. So evaluating it up would give us part C as our final answer. So question number 33 says that 10 cells of each EMF 1.5 volts are connected together as shown. What is the combined EMF between terminals X and Y? Among the 10 cells, 9 cells are connected on the same orientation. They provide current in a anti-clockwise manner, positive, negative, but just for this cell, this is connected in an opposite direction. So what we could do is that 9 into 1.5 minus 1.5, so that would give us 12 volts. So C is the appropriate answer. Now question number 34 says that an EMF is shown with its internal resistance R and a variable resistor V. It says that which shows the graphs of the variation of the potential difference V across the internal resistance with the potential difference capital V across the variable resistor. So first thing first, E is equals to IR plus IR and E is equals to IR plus V. Considering this as our small v and this is our terminal potential difference, so small v, which is on the y-axis, equals negative v plus e. So that would become a graph which would be something like this. So from the options we have either A or C. B and D eliminate. So now let's see, when it's R, when the external variable resistor is R, what is the potential difference across the internal resistance? What is the value of V? So when it is R, so that would be R over 2R into E. So that would become E by 2. So E by 2 would be across this and E by 2 would be across the variable resistor. So at initially it would be over here 0.5 or over here, so that's the same. So when the external variable resistor is increased, when the external variable resistor is increased to 3R, the potential difference, the external potential difference must increase. So the value of V must increase. So considering from A and C, the x-axis, the value of x-axis must increase. So that is over here. Over here, the value of V is being decreased. So A is the proper answer. So question number 35 says that each of the Kirchhoff's two law presumes that some quantity is closed. Which law states Kirchhoff's first law and names the quantity that is conserved? Kirchhoff's first law, the statement is regarding the current and the quantity being conserved is charge. So A is the appropriate answer. So question number 36 says that a cell has an electromotive force 8 volts and negligible internal resistance. The cell forms part of the circuit. The reading V1 is 4 volt, the reading V2 is 4 volt, this is 4 volts, this is 4 volts. So the resistance, they are in series, so the resistance must be the same. So 4 parallel with 4 makes up 2 ohms. So the R value must also be 2 ohms. So B is the appropriate answer. So considering question number 37, we need to find the value of R. Considering this, both resistors are in series, so across 3 the voltage is 3 over 3 plus 9 into 4, which makes up 1 volt, and that makes up 3 volts. So that's 3 volts, that's 1 volt. So the same would be the terminals, that's a 0 point, so they would be the same over here. So that node is a 3 volt point, because that's 4 over here, so that would be a 3 volt. So that must also be a 3 volt point over here. So if this is 9 volt, so in order to make this 3 volt, there must have to be a voltage of 9 minus 3, which is 6 volts over here. And similarly, there must have to be a voltage of 3 volts over here. So applying the potential divider formula, R over R plus 6 into 9 equals 6, and that would make R equals 12 ohms. So C is the appropriate answer. So question number 38, it says that when alpha particles are directed at a goal leaf, observation number 1 is that almost all alpha particles pass through without deflection. Observation number 2 is the few alpha particles directed through large angles. What are the reasons for these effects? So C, the gold nucleus is very small, so most alpha particles miss all nuclei. That seems correct for observation 1, and occasionally the path of an alpha particle flows from nucleus. So C is the appropriate answer. So question number 39 says that a nucleus X is radioactive and decays into a nucleus Y. X and Y are isotopes of the same element, so they have the same proton number. So if this is X, A, V, so that's Y, B, Z. So the proton number must remain the same. So it says that which combination of particles could have been emitted during the decay process. Let's check. One alpha particle, one beta particle. If one alpha particle is being emitted, so it would have it would decrease the proton number by 2, so we need 2 beta particles. So one beta particle is wrong, one alpha particle, 2 beta particles, so this seems to be the correct answer. So question number 40 says a positively charged meson consists of a quark and an antiquark. What could be the quark and an antiquark? It could be a strange up and an anti-strange. Considering that up is positive 2 by 3e and down is minus 1 by 3e, you can recall the table which is being given to you. That's it for this video. Do like and subscribe my channel for more videos. Thank you.